Welcome to Making Democracy Work, a monthly program brought to you by the League of Women Voters of Honolulu. Today, we're going to discuss an important topic to all of us, and we have to discuss with us the water supply of Honolulu. With us today is Barry Usugawa, who is the
Water Resources Program Administrator.
Water Resources Program Administrator for the Board of Water Supply. We're going to discuss the sources of water of Honolulu, how it's being used, how we get it, and all of the things that we think are important about water. So Barry, let's talk about, first of all, the most important resource for our water, which is that big lens of water. Could you put on that first, is it the number 1 graphic?
It is number 2.
Okay, the number 2 graphic, please. Okay, so can you explain that to us, how this is a really important source of water for us?
Well, thank you, Pearl. I appreciate you inviting the Board of Water Supply to your program. Oahu's water supply is made up of freshwater lens sitting on top of seawater. The island is porous lava rock, so as you can see a cross section there. Think of lava flow over lava flow, very porous lava rock in several places. It's like a rock sponge, if you will, and the fresh water comes from rain. It percolates into the ground, and just through density differences, it sits over the seawater. The aquifers are very fresh. The lava rock does a great job at filtering. It's in places 25 years old, as old as that, and it moves very slowly, but it's as much as 700 feet thick in places.
So Oahu is quite fortunate in having this thick lens of fresh water sitting on top of the salt water.
Mm-hmm.
And so we tap into it
Mm-hmm.
to get our water. We pump water out of there.
Right.
And then I saw on the graphic that there were artesian wells, which means that they don't have to be pumped.
Some of the wells are under natural pressure conditions called artesian. Others have to be extracted through pumps or shafts. And then, like on the windward side, there's high-level water in what's called dikes, which are the high-level water. They're up at 700-800 feet above mean sea level, where the basal aquifer is roughly about between 10 and 25 feet above mean sea level. The windward side dike tunnels are gravity flows.
Oh, that's interesting. So is there any danger of over-pumping? I have heard that if you ever penetrate that border between the ocean water and the fresh water, that is disastrous.
It's called seawater intrusion.
Yes.
There are a couple of ways that could happen. One is that we overpump our wells. And so if demand rises too quickly, if people do not conserve water, and by the way, it is a precious resource.
Yes.
If the wells are pumped too hard, it will start to pull up salt water through through the wells and contaminate the source.
So is the Board of Water Supply making sure that we will never do that?
Yes, us along with the State Commission on Water Resource Management has a concept called a management tool called sustainable yield. And sustainable yield is a mathematical calculation of the hydrologic cycle. So it's the amount of rain that's falling on an aquifer, how much of that is lost to evaporation and transpiration, how much is lost through runoff, and the remaining is recharged into the aquifer. The sustainable yield then becomes a percentage of that amount of recharge. And so it is, by code definition, the maximum amount of water that you can draw from a well in perpetuity.
And this is
there's
monitored daily, hourly, monthly? How do you monitor that?
monthly.
Monthly.
And
I
it's,
see.
there is a ceiling that we cannot exceed. If we exceed that, we're overpumping.
And then what?
Well, we
People have
just, we don't exceed that. Otherwise, we're destroying the resource potentially.
Right. So, okay, if you're ever in danger of exceeding that, then there is rationing or something like that?
That's correct.
Yeah.
When we have severe droughts, like we had a unprecedented 6-year drought from 1998 to 2003. Every year we started with less water than we had the previous year, and our water levels were dropping. In 2003, we recommended to our board of directors, and they approved a voluntary conservation program so that we could ask people to cut back. And so we didn't get to rationing but basically there's a lot of smart behavioral uses of, how you use water and waste less. So you reduce your washing cars, you do less water fountains, you irrigate only certain times of the day. So there are a lot of what's called best management practices along conservation. And when we made that call, people responded, and as they usually do, and the head levels started to rise again. And then it allowed us to ride through that drought. And the following year started raining, and so we got out of it.
All right, now agriculture uses a lot of water. What does the Board of Water Supply have to do with agriculture?
So in two things. One is we have a number of farmers that are our customers. About 3% of our rate base is agricultural farmers, of which we give a subsidized water rate. The other way we help farmers is in our planning to ensure that overall in the island there's enough water for not only people and urban uses, but for agriculture as well as environmental uses and cultural uses of waters tied to streams. And so our approach is that it's a balanced approach, that there should be enough water for all uses, people, agriculture, and the environment. And so our planning accounts for agricultural use in that way.
Do you actually supply, 3% of the water usage doesn't sound like much, so that the farmers who are growing food for us, how do they get water from the Board of Water Supply?
Well, we only serve those farmers that don't have access to either a stream or their own well, or a stream diversion or a ditch system. There's 3 large ditch systems on the island: Waihole Ditch, Kakunahua Ditch in the North Shore, and the Waimanalo Ditch the state owns for Waimanalo farmers. I guess there's 4. There's one in Punaluu as well.
I see.
And
that is outside of the Board of Water Supply?
That's correct.
I see.
And a stream diversion is actually cheaper water because farmers have very little economic margin.
Yeah.
So that is the more appropriate water supply for them. We serve those farmers in Waianae, some in Waimanalo, some in the back of Waikai, where there's no other access to irrigation water.
I see. And they get a special agricultural rate.
Right. It's roughly about half.
I see. Let's talk about desalination, which I've had a number of questions about. What is the Board of Water Supply doing about desalination?
Well, our approach is that is a diversified approach. We have, pardon me, but we have 3 strategies water resource strategies that we pursue. One is to preserve and manage the watersheds, because it's important to ensure that the natural water supply is always there. Second is conservation, demand-side management, water use efficiency. We're very successful in those areas. And the third strategy of which your question is a diversified water supply system that takes advantage of not only natural groundwater, but surface water, recycled water, and desalination. So desalination is one, if you will, one arrow in our quiver of water supplies that we, in a diversified system, can plan for and construct to meet Oahu's future demand. So along those lines, desalination, we're planning for that, but if we can push desalination out into the future as far as we can, that's a good thing. And so we've been able to do that so far.
I've read that there is already a desalination plant that is in operation.
No, but we have a desalination plant at Honolulu Water Recycling Facility where we desalinate recycled water for industrial processes. So we provide demineralized water for instance, HECO's Kahe power plants, Chevron's refinery, the Tesoro. So the refineries and the power plants in Campo Industrial Park are served by desalinated recycled water.
Oh, so this would be the water from the sewage plants.
Right.
It seems like I read, you see, when I'm not sure, it was online, and I saw something about a desalination plant being opened, and then that the Board of Water Supply said that there were 3 wells of brackish water that were being desalinated. Was that just a temporary thing?
So the state, back in the mid-90s, piloted and they constructed a demonstration brackish desalination plant. It's in Kapolei. They only ran it for about 5 years, and then they closed it. Subsequent to that, it was transferred to the Board of Water Supply, so we own that property. We have 2 properties. One is that particular brackish desal plant, and we have one further Makai in Campo Industrial Park called the Kalalau Seawater Desalination Plant. But those are not enough. Both are basically just wells in the ground. There's no desalination facilities there.
I see. So this Kalalau seawater desalination, it would be getting water from the sea?
We have deep wells that we've drilled and tested. We piloted the reverse osmosis membrane desalination technology, made fresh water, and gave us some valuable information for design. But then we didn't need it, so we closed it up. But it would be deep wells, and then of course, when you make fresh water from seawater, the byproduct is brine concentrate.
Yes.
And so several the 2 largest issues with desal is, aside from cost, is brine concentrate disposal. In the Campo Industrial Park, a lot of the refineries there and the power plants, they use seawater for cooling. They inject that coolant seawater into the ground because it's an injection control area. And so we would do the same for the desal plant. What we don't want to do is pump brine concentrate out into the ocean, because that would kill fish life. If you put it into the ground, it eventually will diffuse and dilute.
Yes.
And it would be below the benthic level of the seafloor. So we found in our studies that would be the most environmentally correct method of disposal.
And so the Kalalau desalination plant would actually be using ocean water, not brackish water.
Yeah, that would be a seawater well, and it would be larger, of course. The brackish desal plant is limited because there's limited brackish water. So we have only a 1 million gallon per day brackish well on site there. So it only can make something like 800,000 gallons per day.
I see.
It's limited because you need fresh water to make brackish water. You know, it's a proportion. And the brackish aquifers in the Everplain has diminished quite a bit since the plantations closed, because it was artificially created because they kept pumping irrigation water up,
I see.
and it recharged the aquifer and was pumped up again, so it was just going up in circles. And when you do that, you created this brackish
Right.
aquifer that has since dissipated since the sugar plantations closed.
I see. Now, let's talk about development. The League of Women Voters has been very concerned with the new developments, Ho'opili and Koa Ridge. And one of the things that we're concerned about, of course, is the water supply for all these new homes. Would you talk about that, please?
Well, the first thing to realize is that these were, I think part of the controversy is also that they're developing agricultural lands.
Yes.
Those agricultural lands had a water supply that was used to irrigate it. So they're essentially just using the same supply, but for a different use. Now, I know that rubs people the wrong way, especially because, yeah, I mean, we need to support agriculture as well. But say for Ho'opili, they would be drilling a well for their development and tying into our system there. For Ho'opili, we already have we've constructed a drinking water source, and they would just be hooking up to that and pay our hookup fees. But the strategy for development has got to be towards resource management and being green and being light on the carbon footprints. So we've been working with, as part of the land use requirements for Ho'opili, for instance, as well as the entire Alva, they have to put in dual water systems. In other words, one for drinking and one for irrigation. And Ho'opili is no different. They'll put in two pipelines, and therefore they have an old Oahu sugar brackish well, but we're also planning to one day connect it to our recycled water plant. But the whole idea there is to match quality with use. So the high quality drinking water should not be used for golf course irrigation.
Right.
Should not be used for putting it on the ground. It's for people to drink. And so the dual water systems do just that.
The recycled water, would that be the same system as the one that you're using for Campbell Industrial, or is it a different recycled water?
It comes from the same plant. It's called Honolulu Water Recycling Facility. But the facility makes two grades of water. One is irrigation grade called R1, and the other is industrial process, high quality demineralized recycled water. That's what goes to the power plants. So our irrigation grade system at Honolulu provides water to all of the golf courses in that area, all except Ko'olina, which has their own non-potable well. We also serve schools, roadway landscaping along Fort Weaver. We'll eventually connect to the city of Kapolei. We're trying to expand the recycled water system to all of the non-residential areas. And we've had talks with Kalalau as well to expand it because that stretches the potable resource.
You told me something interesting before we started, that the EVA development has directed that there be two water systems for, could you explain that part to me?
As part of the constructing or writing of the EVA development plan, we had worked with the Department of Planning and Permitting and their consultants to see what we can do to conserve the water resources and still provide for growth. And so as part of the policy for the entire EVA area, dual water systems are required. It's to the point where when developers do come into the Board of Water Supply and ask for potable water, we can, of course, we allocate water to development, but only if they also have a non-potable meter as well. So in that way, we are able to implement the dual water policy in the development plan.
I see. Hmm. Now, you said Coral Ridge would be drilling its own well. What aquifer is it going to be drilling into? I mean, I'm not even sure if aquifer is the right term.
No, that you're correct. It would be the what's called the Waipahu Waiawa aquifer system area is the official title. It has a sustainable yield of 104 million gallons per day. And just to put it in perspective, 1 million gallons per day can serve about 2,000 single-family homes. Of the 104, we're pumping only about 55 MGD, so just a little over half.
Right now is
Right
being
now,
used.
yeah. In terms of permits, it's up at 86 or so MGD. So there's still available capacity if you subscribe to the sustainable yield number that the state uses and we use to manage our resource.
So that right now, about 55 is being used, but the well will be tapping into that same aquifer and using another portion of it.
Yeah, I think they would be in the range of about 2 million gallons per day.
I see. Okay. Now, another thing that is dear to your heart, I'm sure, conservation. And you have a graphic that you want to put up about how the Board of Water Supply has been so successful in conserving water, which I found very impressive.
Yeah, if I could see slide 9, please.
You say that we are actually using less water now than we did. That's not the one, is it?
Well, it's not showing the graph.
Okay.
It would be. But anyway, what that shows is, or would have shown, is that from 1990 to now, Wahoo, the Board of Water Supply System island-wide, has dropped 9%. We were pumping at 157 MGD back in 1990. Now we average 145 MGD. So that's about 12 MGD less than what we were using in 1990.
With a much greater population.
Yes, because
the population increase has been what?
Well, I believe in 1990 it was in the range of 800,000 people. Now with tourists, we're close to 1 million.
Oh.
And of course, in 1990, Ewa was sugarcane. Mililani Mauka has not been built. So there's been a lot of growth out there, and yet water demand has gone down. The reason primarily for that is that it was inefficient water use.
Right.
And it exists on several different planes. One is low-flow fixtures. That technology really jumped and improved since 1990. We started a conservation program, the Board of Water Supply did in 1990s. So now low-flow toilets, for instance, was a big savior. Prior to that, the toilets would flush 5 to 7 gallons per flush, and it would take a whole minute to flush, right? And another, half a minute to flush, and about a minute and a half to fill back up. Now, with the low flow, they go to 1.6, 1.28 gallons per flush. So there's a porcelain graveyard out there, Pearl, that all of these toilets have been replaced. That was big for us. The other thing was our recycled water program, which because we replaced potable water used for industrial processed water in Kamo Industrial Park, we saved another 1.5 million gallons per day. And then from 2005 on is when we had to start, we and the Department of Environmental Services, the sewer, started raising rates because of aging infrastructure. And that's where the economic incentive to conserve really started to kick in. And as people, because people have the control now, if they feel that their water and sewer bill is too high, we have ways that we can offer them through our conservation programs to reduce their bills through conserving water through various ways. Rain barrel catchments, leak detection and repair, There are various low flow fixtures.
And they can
zero
just
skate
call the
irons.
Board of Water Supply and ask for help.
748-5000.
I would like to recount my own personal experience with a low flush toilet.
Yeah.
We have only one bathroom in our house. We put
Oh
in
my.
a low flush toilet, and our water usage went down by 35%.
Wow.
I keep track of the gallons that we use, not the dollars.
Yes.
And so I was really amazed. Now we have only 2 minutes left, and I know you wanted to say something about the Board of Water Supply. There was a graphic that you wanted to put up?
I believe I
all
did
right.
talk about that, but yeah, thank you for the offer, because yes, conservation, infrastructure is important to us. We are trying to ensure to our customers that we are on the ball. We have to do with aging infrastructure, and we have a large effort to improve the way we do our capital improvement planning, so that we utilize the revenues from people's rates in the best way, most efficient way possible. So infrastructure, conservation, resource management are all, source water protection, they're all positive programs that the Board of Water Supply is doing. And it's just, I appreciate the opportunity to explain a little bit of it today.
I do have a question. It seems that a year ago, every week, there was a water main break, but I don't hear so much about that anymore.
Yeah, we've actually had a reduction in main breaks recently, just this past year. Usually our high period for main breaks is from summer through the beginning of winter. And it really had dropped down. We had as much as 400 to 500 main breaks a year, and now we're averaging in the 350, low 300s. And that's because of our a couple of things. Our systems operations. A lot of the main breaks are caused through pressure spikes, and we've made some important improvements in how we pump water, as well as replacing mains in a timely fashion.
I really appreciate your coming here to talk about this.
I do too.
Barry Usagawa of the Board of Water Supply. They supply fresh water to us and do a very good job. Thank you very much.
Thanks
I'm
again,
Pearl
Bob.
Johnson with the League of Women Voters, Chair of Planning and Transportation. Thank you.